Welcome to the deep dive. We're jumping straight into a really fascinating development in AI today.
Yeah, it's something that's been gaining a lot of traction.
You've pulled together some great resources for us, and our goal today is really to distill the essential understanding you need about the Model Context Protocol, MCP for short.
Exactly. We've got insights from YouTube explainers, folks like Krishnanki, Jack Harrington, Builder Central, Greg Eisenberg with Professor Ross Mike, Code with Chris, IBM Technology. Quite a range.
And also the official stuff, right? Announcements from Anthropic, the actual GitHub docs for MCP.
Yep, covered those too.
So your mission, if you choose to continue listening, and we really think you should, is to grasp what MCP actually is.
And why it's important, why it's making waves.
And crucially, how it's starting to change the way AI interacts with, well, everything online, without getting totally bogged down in the weeds.
Yeah, we'll keep it practical. Maybe think of it like this. Remember the mess of different charging cables before USB-C?
Oh, yeah. Total nightmare. One for everything.
Right. MCP is kind of aiming to be the USB-C for AI integrations, sorting out that connection chaos.
Okay, I like that analogy. So let's unpack this. Before MCP, what was the situation? What were these LLMs actually doing or not doing?
Well, you had these large language models, LLMs, like, the brains behind ChatGPT or Claude, super powerful, incredibly good at predicting the next word based on all the data they were trained on.
Amazing language skills, understanding, generation?
Absolutely.
Yeah.
But, and this is the key thing, they were pretty isolated. On their own, they were just sort of manipulating text based on their training.
So limited to that internal knowledge, they couldn't just look something up or book a flight.
Exactly. No built-in way to perform real-world actions or access external up-to-the-minute information. They're working off past data.
Which is where those hallucinations come in, giving wrong answers confidently.
Precisely. If the answer isn't clearly in his training patterns, or if things have changed since training, it might just generate something plausible but incorrect. It lacks current context.
Okay, so clearly, to make them useful for more than just chatting, you needed to connect them to stuff.
That was the logical next step. Developers started figuring out ways to hook LLMs up to external tools, databases, APIs.
Like how Perplexity uses web search, maybe?
Yeah, that's a good example. Or tools like Cursor for coding, which need access to your actual codebase files, giving the LLM eyes and ears and sometimes hands on the outside world.
But hang on, connecting all these different AIs to all these different tools, that sounds complicated fast.
It was complicated. Extremely. That's the core problem MCP addresses. Imagine you have, say, 5 different AI applications.
Okay.
And you want them all to potentially talk to your email, your calendar, a product database, Slack, GitHub, maybe some internal company tools.
Yeah.
10 different things, let's say.
Right, I can see where this is going.
Before MCP, you'd likely need to build a separate custom integration for each of those connections. So 5 apps times 10 tools, potentially 50 unique integrations.
50 unique pieces of code to write and maintain.
Exactly. This is what people call the MXN problem. M applications, N tools, leads to M times N connections.
Wow. That's not scalable.
Not at all. Massive duplication effort. And super brittle, too. If Slack updates its API.
You have to go fix the Slack integration in all 5 of your apps.
Potentially, yes. It creates inconsistent implementations, huge maintenance overhead. It was a real bottleneck to building more sophisticated, integrated AI experiences.
Okay, so that paints a clear picture of the problem, the MXN integration nightmare. So how does MCP swoop in and save the day?
Well, save the day might be strong, but it offers a much, much cleaner approach. The Model Context Protocol, MCP, is basically an open standard. Think of it as defining a common language, or like we said, a universal adapter.
USB-C port for AI.
Exactly. It standardizes how the AI applications, let's call them clients in MCP terms, talk to the external data sources and tools which connect via servers.
So it's aiming to simplify things dramatically. How does it change that MXN calculation?
It aims to turn it into an M plus N problem, which is, way better.
M plus N, how does that work?
Instead of M times N connections, the idea is each tool creator builds one MCP server for their tool, and each AI application developer builds one MCP client into their application.
Ah, I see. So the tool connects once via its server, and the app connects once via its client. They meet in the middle using the standard protocol.
Precisely. So you have M clients plus N servers. Much more manageable, much more scalable. It really frees up developers.
Okay, that makes sense. So what are the key pieces of this MCP setup? You mentioned clients and servers.
Right. Let's break it down. First, you have the MCP host. This is the main application the user interacts with.
Like the Claude desktop app, or maybe my code editor like Cursor or Windsurf?
Exactly. Or it could be a custom AI app someone builds. The host contains one or more MCP clients.
Okay, so the host is the user-facing part. What does the client do?
The MCP client lives inside the host. Its job is to manage the specific connection to an MCP server. It's a one-to-one link. One client talks to one server.
Got it. And the server is the bridge to the outside world.
That's the one. The MCP server is usually a pretty lightweight program. Its role is to expose the capabilities of whatever external system it's connected to, but it exposes them using the MCP standard.
Capabilities like?
Things like tools, which are basically actions the LLM can ask the server to do, like send an email or query database. Then there are resources, which is data the LLM can access, like files or database records, and sometimes prompts, which are like preset templates to help the LLM use the tools effectively.
Okay. Tools, resources, prompts, exposed by the server.
Right. And finally, behind the server, you have the actual data sources and services.
The real things it connects to: databases, APIs for Slack, GitHub, whatever it might be. Local files even.
Yep. Local files, databases, remote APIs, you name it. The server acts as the standardized gateway to those underlying systems.
Okay. The architecture is becoming clearer. Host, client, server, data source. How does it work in practice? Like when I ask my AI assistant to do something that needs external info.
Let's walk through a typical flow, simplified a bit. It starts with initialization.
Okay.
When your host app starts up, like Claude Desktop, any MCP clients inside it connect to their configured MCP servers. They do a sort of digital handshake, exchanging info about capabilities, protocol versions, making sure they can talk.
Right. Establishing the connection. Then what?
Then comes discovery. The client asks the server, hey, what can you actually do? What tools, resources, prompts do you have?
And the server replies with its menu, basically.
Exactly. It sends back a list and descriptions of its capabilities. Now, the host application, and potentially the LLM, knows what's possible through that server.
So the AI is aware of the tools available. How does it get set up to use them when I make a request?
That leads to context provision. Based on your specific request, the host application figures out which resources or prompts might be relevant and makes them available to the LLM's context. For tools, it often needs to format them correctly.
Formatting, like translating them into a language the LLM understands.
Sort of, yeah. Often translating the tool's description and parameters into something like JSON function calling syntax, which many LLMs are trained to use. It's preparing the tool for potential use.
Okay, makes sense. So the LLM now sees my request, has context, and knows about formatted tools. What if it decides it needs to use one?
That triggers the invocation step. The LLM signals its intent to use a specific tool. The host application then tells the corresponding MCP client, okay, send this request over to the server.
So the message goes from host to client to server.
Right. Then the server takes over for execution. It receives the request, say, get the status of Project X from Jira. The server then performs the actual action.
Calling the Jira API in that example.
Exactly. It does the real work, interacting with the underlying data source or service, and gets the result of the project status.
And then sends that result back.
Yep, that's the response phase. The server sends the result, the project status data, back to the MCP client.
Client gets the data.
And passes it back to the host application. This is the completion step. The host takes that fresh external data and feeds it back into the LLM's context.
So the LLM now has the answer it needed from the outside world.
Precisely. And now it can generate its final response to you, incorporating that real-time specific information. So it's this cycle. Discover, prepare, invoke, execute, respond, complete, all standardized by MCP.
That flow makes a lot of sense. It seems much cleaner than everyone building custom pipes. So let's talk benefits. Why is this a big deal? Why should people care?
Well, the biggest one is simplified integrations. That's huge. Moving away from that MXN nightmare we talked about. Less custom code, faster development.
Which naturally leads to better scalability, I imagine.
Absolutely. It becomes much easier to connect your AI to a growing number of tools and data sources. If a new service pops up with an MCP server, integrating it should be relatively straightforward.
Does it also give you more flexibility? Like, could you swap out the underlying LLM more easily if everything talks MCP?
That's definitely one of the potential advantages. In theory, if your AI application is built around MCP for its external interactions, and multiple LLM providers support that standard,
then switching between, say, Claude and a model from OpenAI might be less painful, focusing just on the core model swap rather than rebuilding all the integrations.
That's the hope, yes. How seamless it is in practice, might depend on, specific implementations and how different models handle the context, but the protocol provides that common ground.
It also sounds like it lets developers focus more on the AI's task and less on the plumbing.
Exactly. Focus on the what, not the how. What do you want the AI to do? Let MCP handle the standard connection details. This could make AI orchestration more accessible too, even for folks who aren't deep coders, setting up integrations more easily.
And you mentioned maintenance before. Does MCP help there too?
Yes, significantly. The service provider takes responsibility. The company providing the tool or service, like Slack or GitHub, builds and maintains their MCP server.
So if they change their internal API,
They update their MCP server to match, ideally without breaking things for all the clients connecting to it via the standard protocol. The integration burden shifts to the service provider, who knows their system best.
that seems like a much better model. Is this actually happening? Is there an ecosystem building up?
There really is. We're seeing more and more pre-built MCP servers appearing for various services. There are also tools emerging, like an MCP inspector, to help developers test their server implementations.
And big names are getting involved.
Yeah, players like OpenAI have announced support. Anthropic is obviously heavily involved with Claude. It signals that this isn't just a niche idea, it has industry momentum.
Okay, it's always helpful to ground these things. Can you give some real-world examples of where MCP is making a difference or could?
Sure. Think about an AI assistant on an e-commerce site.
Okay.
Using an MCP server connected directly to the live product database, it could give you really accurate, up-to-date recommendations based on current stock, features, maybe even your past purchase history if that's exposed.
Much better than generic suggestions. Direct data access.
Right. And then maybe it uses another MCP server, this one connected to the order fulfillment system.
So it could actually place the order for me.
Potentially, yes. Check stock, confirm details, initiate shipping, handling the transaction via standardized MCP calls to the fulfillment server.
Moving from information retrieval to actual task execution. That's a key step.
Definitely. Or think about business intelligence. You could have Claude, through MCP servers, connect directly to your company's sales database, maybe your CRM.
And analyze trends. Ask questions about performance.
Yeah, exactly. Analyze sales data. Generate reports, maybe even create charts, all by querying these systems through their MCP interfaces, rather than you needing to manually export and feed data in.
What about for developers? You mentioned Cursor.
Yeah, IDEs like Cursor or Windsurf are using MCP to connect the AI assistant directly to your codebase, documentation sources, maybe even Git repositories via a GitHub MCP server.
So the AI can understand my code, find relevant docs, maybe even help stage commits.
Things like that, yeah. Better code completion, finding bugs, understanding context across files, making the AI a much more integrated coding partner.
It sounds like it could automate a ton of workflows, too.
That's another huge area. If you connect your AI via MCP to something like Zapier, which itself connects to thousands of apps.
Oh, wow. So the AI could then potentially interact with my Gmail, Calendar, Slack, Trello, whatever Zapier supports.
That's the idea. Triggering automations, summarizing information across apps, creating personalized workflows based on events happening in your different tools, all orchestrated by the AI through MCP.
Okay, this is powerful stuff. What about the nitty-gritty? Any technical details we should be aware of? Like, how do these clients and servers actually talk?
Yeah, a couple things. One is transports. MCP isn't tied to just one way of communicating. For local connections, maybe client and server on the same machine, it can use Stadio standard input-output.
Okay, like a direct pipe.
Pretty much. For remote connections over a network or the internet, HTTP is common, often using service and events, or SSE, for efficient streaming of messages from the server to the client.
SSE, yeah.
And there's also work on newer, potentially more efficient HTTP methods involving things like JSON RPC batching to reduce overhead. Basically, different ways to ship the data back and forth depending on the scenario.
Makes sense. And security. If these servers are gateways to important systems, how is that handled?
Crucial point. Securities is built in. For remote connections over HTTP, MCP mandates using OAuth 2.1 for authentication.
OAuth 2.1, that's a solid standard protocol for authorization.
Exactly. It ensures that connections are properly authenticated and authorized, managing access tokens and API keys securely, so only the right clients can talk to the right servers and access the right data.
Good to know that's baked in. How mature is MCP overall? Is it fully baked or still developing?
It's definitely gaining momentum and seeing real adoption, but I'd say it's still evolving. The core standard is there, but best practices are still emerging.
So setting up a server might still involve some command line work or configuration files.
Yeah, sometimes setting up or configuring servers might require a bit more technical fiddling right now. You'd expect that to become more streamlined, maybe more user-friendly interfaces over time as the ecosystem matures.
Okay. Stepping back then, what's the bigger picture here? Where does MCP fit into the future of AI?
I think it's a really fundamental building block for the next wave of AI, truly context-aware AI.
Meaning AI that's not just smart with language, but deeply plugged into our actual tools and data.
Exactly. By standardizing these connections, MCP makes it feasible for AI to be much more integrated into our workflows, our digital environments. Less isolated, more genuinely helpful because it has the right context.
It could also create totally new business opportunities, couldn't it? Services built around MCP.
Absolutely.
Yeah.
Standardization often breeds innovation on top. You could easily see new opportunities emerging, companies offering specialized MCP servers, platforms for discovering and managing servers. Someone even floated the idea of an MCP app store.
An app store for AI integrations. Interesting.
Yeah, so it's definitely a space to keep watching closely.
Things move so fast in AI.
They really do. And standards like MCP are trying to provide some stable rails for all that development. Staying aware of how these things evolve helps you understand where the most powerful tools are likely headed.
Okay, great discussion. Let's try and wrap it up. If someone remembers just one thing about MCP from this deep dive, what should it be?
I think the core takeaway is MCP is like a universal translator or a USB-C port for AI. It's a foundational standard aiming to drastically simplify how AI applications connect to the outside world of data and tools.
Making AI less isolated, more capable.
Exactly. Moving from that messy MXN problem to a much cleaner M+N world for integrations.
And if people want to learn more or maybe see what MCP servers already exist,
definitely check out the links in the show notes. The official MCP documentation on GitHub is the primary source. Look at the lists of known servers, see if tools you use are starting to offer MCP connections.
And maybe think about your own workflows.
Yeah, think. What tasks could be smoother? What information could be more accessible if your AI tools had standardized, secure access to your other apps and data?
All right. Finally, give us that provocative thought to chew on, something to consider as we see MCP and things like it develop.
Okay, how about this? As these standards like MCP mature and become widespread, how does it change things beyond just user interaction? Will it fundamentally reshape the architecture of software itself? How will information flow when AI can seamlessly and securely bridge nearly any two systems? What completely new kinds of applications or automated workflows become possible when that connective tissue is robust and universal?